Okay, let's start. Good afternoon, everyone. Thank you for joining us for the panel discussion opportunities and risks in open source processes. My name is Frank Riemenschneider. I'm editor-in-chief of Design Elektronik, one of the brands published by Vika Publishing, a huge media house located in Munich. Our business consists on three pillars. We have still a huge print magazine, online business, and also events. And two of our major events you can experience at Embedded World. It's the Embedded World Conference and the Electronic Display Conferences. Both of them are organized by Design Elektronik. Because before I start to introduce the panelists, I want to invite you to ask questions to our panelists after I have finished with my questions. You can use an online tool called slido.com. You can use your smartphone, open just the browser, browse www.slido.com. and enter a code EW19 RISC-V. You can see it on the slide. And after that, you can type in your question and optional your name. It would be great if you would also type in your name, so can I reference the question to the individual who has asked the question. Okay. Let me introduce our high-ranked executives on my side. I'm happy to have them. First of all, on my left-hand side is Markus Levy. He is head of artificial intelligence and machine learning at NXP. And I don't want to read out the CVs in total because we will run out of time. Yes. I have invited Markus because besides his work for the microcontroller division at NXP, he's also responsible for driving the RISC-V ecosystem in his company. Next in row is Tim Whitfield. He is Vice President Strategy Embedded in Automotive, working for ARM. And as you can observe easily, Tim has a lot of experience in IP silicon implementations as well in advanced process technologies. That means manufacturing of silicon chips. Third in row, Ted Marena. He's Director of RISC-V Ecosystem at Western Digital. He's also the marketing chair of the RISC-V organization, which he joined in 2016, and is pushing RISC-V within the company and also the ecosystem. And last but not least, Cesare Garlati. Yeah, my wife is English teacher, you know. He is the Chief Security Strategist at the prpl Foundation, and he also founded a company called RISC-V Security, which created the first trusted execution environment for RISC-V. Thank you guys for joining me, and I hope we will have a fruitful discussion. Before we start, let me point out that there are several similarities between both instruction sets. Both RISC-V and ARM's ARMv8 architectures share the same RISC roots going back in the 1980s. Both can boot Linux and other ported operating systems. Both come in 32-bit, 64-bit, and as well 128-bit flavors, and they use them as general purpose or specialist processes. Both have general purpose registers, run multiple registers, loading and saving from and to memory. Both support multiple levels of privilege. Both do virtual memory and access protection. And both run software written in C, C++, Python, and other languages. So to programmers, the architectures appear quite similar. The intention of the discussion is to point out the differences from the point of view of customers, semiconductor manufacturers, and of course RISC-V and ARM IP vendors. And all of them are represented at our panel, so I'm looking forward to receive great answers. Okay, so which topics will we discuss? First of all, what about the cost to build a reliable SoC? Secondly, the software and tool support. Third, security, certification, functional safety, very important for the embedded world, not just for the exhibition. Fourth, standardization, platforms and frameworks, also very important for setting up useful software applications. And last but not least, the question how to build and maintain an ecosystem, which means IP, foundry support, and of course EDA support. Okay, so let's start. I have to change from PowerPoint to another. Okay. So my first question goes to Markus. Markus, anyone can use RISC-V for all types of implementation, including development, commercial, open source implementations without any costs. But how big is the cost saving in reality if you consider the total cost of taping out a SoC? Can you give us an idea which proportion the license fees or royalties of commercial offerings are in total SoC development?
Well, first I want to comment that I lost my voice this morning, so bear with me a little bit. So let me just use sign language to give you the answer to this question. 0, or very close to it. So, you know, everybody immediately starts to think RISC-V is free, so it's going to offer advantages over ARM in that regards. But by the time you consider all of the support that you go into building an SoC, and this is not just the hardware side, but it's also the bring up of all the software pieces and everything else, that it really is not a factor in this equation. So I don't want to steal the show here, but I mean, I could keep proliferating on this particular topic, but from our standpoint, well, I can't really get into the details of the pricing negotiations with ARM, but if you look at some of the lower end chips, like especially MCUs, it's almost becoming negligible on the difference. And so I guess that's sort of the short answer to that question.
Thank you so much. Tim, many product developers don't have the big budgets for licensing fees, often quoted as a huge barrier to entry for system-on-chip design. ARM license fees are widely reported to range from $1 million to $10 million. Does ARM need new business models to reduce the entry barrier to survive the RISC-V challenge?
So I've read those articles as well. I think I would refute the numbers that you read in the press, and clearly we don't disclose our license fees, but we spent a number of years in business and evolving our licensing model, and there are much more cost-effective ways of entering into the ARM ecosystem. We have things like Design Start, which offers some of our deeply embedded cores at 0 licensing fee. And depending what you're doing, you can trade licensing and royalty and build a model that suits different pockets. And so do we need to evolve? I think we already are. Design Start we've had for around about 10 years. It sort of precedes any of the real commercial RISC-V activity. And we've added cores. We added this year, or back end of last year, we added our Cortex A5 core to that Design Start model, which is our entry level model. Now, if you're a big company who is negotiating a license deal over a long term for access to lots and lots and lots of cores, then clearly there are going to be different value points. But I think we offer a range of licensing models that suit all sorts of SoC design starts. And do we need to continue to evolve? Absolutely, absolutely.
Okay. that RISC-V has the advantage of being able to tailor purpose-built machines that are architectured to handle specific data sets in specific use cases very well. But what about the risk of fragmentation, which could influence long-term costs and support issues for software and tools? How does RISC-V plan to resolve this issue?
So, is this working? Okay. So I think the terminology that we like to try to use is fragmentation is definitely not something that we want to happen, right? So the organization and the RISC-V community overall is very aware that this is a significant and critical issue to make sure that it doesn't occur. But I think some people get confused between fragmentation and diversity. And so this is one of the areas of RISC-V that I think is of high interest, is the fact that the way the instruction set is configured and organized does allow for some flexibility. Custom instructions, for example, are available. And so I think there's a little bit of a difference that sometimes people get mixed up. So that's my response.
Okay. Cesare, in a SoC, CPU IP is just one part. Let us assume that a strong community backs RISC-V and it offers all the IPs and tools needed for building SoCs. However, the question remains whether companies building custom SoCs will take the risk of using a community-backed instruction set?
Right. So I would like to go back just 1 minute to part of your initial question,
yes,
if that's fine.
Please.
So I think we missed a little bit the point when we look at costs and whether it's licensing or not. How many of you know about Linux? Raise your hand. How many of you run Linux? There you go. How much you save by running Linux? That's not really the question. The question is, what are the benefits of open source? And open source is about, that's my experience being in technology all of my career, being in control of the technology strategy. What you get with open source is the ability to be completely decoupled from your vendor, in this case, and drive your own roadmap, which means you can have extreme customization, you can have extremely rapid time to market, you are really in control of what you do. Now, the licensing, without disclosing fees, but I work in the industry, even, let me put it this way, even a 5% reduction in cost for some components, especially around IoT, where it's low-cost kind of devices, makes it or breaks it, okay? So that 5% is still relevant, but it's not the driver that I see. When I work with our customers, what I see is a desire to be in control of all the aspects of the platform. So open source, I think, is really the key to RISC-V rather than cost saving. As Linux is not free, especially for organizations that still need to maintain it, deploy it, and there are companies that actually make billions of dollars. I mean, Red Hat is the classical example, right? So it's a public company. So it's not free in the sense of free beer. It's free in the sense of free speech, right? So I can do whatever I want. Now, let's go back to the other question. I'm not the best one to address SoC kind of, I work more on the software stack, so I'm more about on the security side. But I can share my experience. So here at this event, we have a working demo where we have a piece of hardware and we have some software on top of it. That piece of hardware, it's an FPGA and didn't have the Ethernet connected. Very specific example. So I was able to find a developer in UK who in 3 days added that connectivity to the Ethernet. I didn't ask anyone, I didn't sign any license, I didn't sign any NDA. We went on GitHub, downloaded the pieces, and stitched them together. So my SoC is running now, and people who want to see the demo, go to the RISC-V booth, and they will get directed. Does that address your question?
So you don't see any risk initial
I honestly, as far as I'm concerned, I only see the benefits, honestly. But as I said, I don't sell SoCs, I don't develop SoCs for a living. So.
Okay. A second question to Markus. ARM is selling a dozen fundamental IP blocks that wrap around its CPU cores. The IP cores are well supported by foundries and top EDA vendors, and they have been tested to conform with many industry standards and certifications. The resulting platform costs more than cores from RISC-V suppliers, obviously. But doesn't it provide a smoother, faster path to market to use the ARM IP?
Yes, I would say that's definitely the case. I mean, and that's one of the reasons why ARM is so popular. It's not just about the core. It's not just about the ISA. It's about the whole established ecosystem that's behind it. And I'm not just talking about software tools, but I'm talking about IP blocks, as you just mentioned, as well as all of the EDA tools that go to support it. But I also say, you know, and we see this at the RISC-V ecosystem, in a very short period of time has really started to expand, and there's more and more companies that are becoming, actually, the number of members in the RISC-V organization has grown, I think, way beyond anybody's expectations. And I think that these companies that are joining RISC-V are not just there just to kick the tires or to smell the roses. I mean, they're there to seriously partake in the evolution of this ISA. And they're doing it not to compete against ARM. I mean, maybe at some extent it is, but as we've said, I mean, it's not about the cost, right? It's more about the, as Cesare said, it's more about the flexibility of the implementation. And this is how we're viewing it, right? We have no plans today to go build RISC-V microcontrollers or processors as the main processor, but it's more about, you know, subsystems that are in there that maybe customers don't have exposure to, and it gives us the ability to go make what we're calling software-based hardware design. And so we're creating new instructions, and we're, you know, doing our own evolution that is somewhat in parallel with what RISC-V as an organization is doing, where they're releasing new vector extensions, security extensions, and this will become part of the standard that will reduce that part of the fragmentation, but it still allows the flexibility for us to go do our customized implementations. And I think that's where at least our competitors and ourselves, I mean, we see the real value for RISC-V.
Okay. Tim, ARM has a kind of monopoly in certain markets today. By using the ARM instruction set, you get access to proven IPs, a robust ecosystem, software, cloud services, security solutions, silicon vendors, fabs, and also committed support instead of community support. On the other hand, if everybody is licensing the same ARM IP, like CPU, GPU, interconnects, ML acceleration, and so on, connectivity, how can you differentiate your SoC?
Well, I think people have been doing that for 30 years with ARM IP, right? And if you start at the CPU level, then there are, you know, lots and lots and lots of configuration options around, you know, how you configure the CPU, how you configure the IP. You know, and as you move up the stack, you know, there's differences in how you do your security, how you do, you know, then how you write your software. I mean, people have been differentiating with ARM from the beginning, so I don't really see that as an issue. I think it's sort of interesting, you know, talking about this sort of the stuff that Markus was talking about around that sort of you know, being able to do something a little bit differential, and you know, we've integrated other people's IP for years and years and years as well, you know, and there will be places where people want to do something custom, want to do something that's a little bit differentiated, and the ARM ecosystem has absolutely always allowed and supported that, and you know, through standards and through other ways. So I think differentiation is there. I mean, one of the things that sort of gets put out in the RISC-V press a lot is, you know, custom instructions, and then, oh, you can go and do modification to your CPU. You know, we talk to our customers and go, where do you want that? You know, what is it you need? Because there is an awful lot of that configurability already built into ARM IP. And we don't get a huge amount of requests for, oh, we need this. And if we do, we tend to build them into our IP. So I strongly suggest that configurability and differentiation has been ARM's sort of lifeblood as an IP company. If we offered everybody exactly the same building block, then you're right, nobody would use it.
Okay. Yeah. Markus, would you like to comment on this?
Yeah, I was saying that maybe that's a question that you should have addressed to me as the chip manufacturing representative, because I ask this question all the time. And I mean, as you mentioned at the beginning, I run the machine learning part of our company, and so in addition to the hardware blocks, the IP blocks that ARM is providing, ARM is also now providing ARM-NN, which is a tool for translating neural networks into inference engines to run on the technology. And so I asked myself, well, geez, if we recommend this to our customers, how are we going to be different? And I mean, I don't have enough time here because it would probably take the full hour anyway to go into the details of how we actually do differentiate. But if you look at our devices, our SoCs, they are very different than what our competitors offer, and how we put the pieces together. And on top of that, we also have the ability, just talking about machine learning, to figure out how do we differentiate the tools that ARM is providing. And we spend a lot of time working on that. I can't go into details here without an NDA, but there are ways to differentiate.
Okay. Next question to, hello? Hello? Huh? No? Ted Linaro is an engineering organization consolidating and optimizing open source software and tools for the ARM architecture. They are working on IoT, embedded networking, and other topics. Isn't such an organization also critical for the success of RISC-V?
I just wanted to restate your question. So are you saying that the fact that there's just an open source ecosystem, and that's what's going to be required and critical for RISC-V as well, given the large number that are doing ARM today?
No, the question was if organization like Linaro, which consolidates engineering and optimizing open source software, is critical for RISC-V too. Okay, so we are at the point now where there's many things that are been developing in the ecosystem and in the open source community for RISC-V, and as we continue to progress, it is likely that we may have something similar to what folks may understand or recognize as Linaro. So what's being done today is the community is really working in a very collaborative manner. A lot of leading companies that have seen issues and challenges with development in the past. And so we're starting to form the different task groups, technical committees, and so on to address these issues and to combat them. They may not be solved by just Linaro RISC-V 2 or 2.0, right? It may just be a different implementation, but the real key is we want to make sure we don't have fragmentation. We want to make sure that we have the right development and acceleration in terms of tools, IP, all the things that folks will require. Okay. Cesare, RISC-V is an open source architecture and claims to be more secure because of that. From ARM's perspective, all the ARM architecture specifications are accessible to anyone. How can RISC-V claim to be more secure, as architecture specifications are open in both cases and commercial RISC-V IP is closed too?
Great question. That's my role, so happy to go there. Just wanted to touch upon one point there, Linaro. So I don't know if who's familiar with Linaro? Okay, so Linaro is do you want to explain what Linaro is? No, so in 2 words, so it's a consortia, so it's a group of companies that put money, assets, investments, and develop joint software projects for the greater good of the whole world, I guess, because it's completely open source. That's what it is. Well, that's what open source is. That's what RISC-V is. So I don't think we need Linaro. We just look at how many repositories we have online right now. Anyone who wants to add, take a piece, extend. So we are coming from the opposite direction. This is not proprietary that looks into open sourcing something. This is the exact opposite. This is universities. This is community. This is the whole world that is coming together for the greater good of what we do. So I don't think Linaro in the form where it's baked by one single entity might become something for RISC-V. What I think it would be very welcome is for some of the key RISC-V founders to pool some resources together and develop the platform support. Because let's not forget, RISC-V is an ISA. So it's an instruction set. It's a specification for what the core does. But an SoC, a system, has many other pieces, right? And so if the ISA job is not to define anything that goes on outside the core, well, we still need to pull resources and develop those pieces. So I think that's probably where I see this going. Let's get to security now. There is consensus in the security community that security through obscurity, the Microsoft style, never worked. That's why you get the Tuesday patch every Tuesday, right? Because it's closed source, right? So I don't have to convince the world. So I think why RISC-V as a model is more secure is because it starts with definition of standard components, we call them the extensions, but it applies to all the pieces, from the community itself. So nothing is hidden, nothing is secret. Everyone, and when I say everyone, is every nation state. It's not just one state or one government or one government control entity, it's the whole world. Now let me tell you a couple of very specific things about RISC-V that, given that's what we do, makes it more secure. First of all, we have a clean slate approach, so we have no legacy. I don't have to make some old things working, and the more stuff you put on top of stuff, that's called attack surface in security, so that's not good. Simplicity is very good for security, and that's what we can afford because we start from scratch. Everything just is brand new, right? The other aspect that I like a lot is the fact that there are 4 privilege modes, so 4 different ways to cut security, if you want, in the core, and then there's also physical memory protection, which is a very interesting complement to virtual memory and an MMU. This is part of the standard, so no additional cores. I don't need Trust Zone. I don't need any other vendor Trustonic to help me do. It's built into the core. So if you get the RISC-V core, it does that by default. Okay, I stop here, I don't want to take all the time, but I think there are many other aspects that eventually will make this the most secure platform out there. I have no doubt about that.
Okay. Markus, market leaders in the SoC design, like NXP, will develop SoCs including RISC-V IP. You mentioned it before, as it probably increases also your buying power by having some alternative to ARM. However, will NXP be interested in engaging with low-volume customers who need custom processes, or only sell millions of standardized SoCs like ASSPs?
So I don't anticipate that we're going to engage in low-volume designs, primarily because, well, it's not our business model. From a practical standpoint, the support costs associated with any chip is quite high, right? And I mean not just in helping companies, getting their Linux implementations running, but in terms of long-term support with any kind of issues that they have. So it's just not part of our standard process. Is that really what you were asking?
Okay. Yes, thank you. Tim, one of the best-known RISC-V suppliers is a company called Sci-Fi. The more disruptive element of Sci-Fi is not the processor architecture, but the way they are attempting to simplify SoC development and make it easier for anybody to create chips. They promise to get custom SoC in weeks, not in months. Why isn't it possible to simplify ARM-based SoC development in a similar way?
I would say it is. And who is Sci-Fi? Never heard of them. No, they have. They obviously have a very, very interesting approach and model. And again, let's separate RISC-V, the ISA, from what people are doing commercially. And RISC-V, Sci-Fi clearly have some RISC-V ISA-based IP. But what they're trying to do, and very publicly state, is kind of this democratization of SoC design and open up a market to OEMs and developers that is probably inaccessible in cost at the moment. Now, I don't think there's anything in the ARM ecosystem or the way ARM SoCs are developed that means that ARM or a company like Sci-Fi couldn't leverage, ARM IP or ARM or a separate company could leverage ARM IP and do similar things. So there's nothing fundamental. It's, again, not about RISC-V. It's about the approach they're taking to doing this silicon design. Now, time will tell whether that model is successful, whether the volume is there for them. I don't know, but I don't think it's a question about ARM and RISC-V. You could do just the same thing with ARM.
Well, obviously, Sci-Fi is a great promoter of RISC-V IP.
Yeah.
From ARM IP.
Yes, yeah. They are, and they have Open Silicon, who are an ARM licensee and are pushing lots of ARM silicon. So it's an interesting dynamic, and we watch them.
Okay. That a trusted company behind an architecture like ARM or also Intel can steer the ecosystem of software and tool vendors in one direction, driven by customers' needs. In an open environment, isn't there a risk of multiple forces pulling in different directions and delayed decision processes?
Your question is what will cause customers to go in different directions?
Exactly. Yeah.
So, what I can really speak is, for example, what like Western Digital is doing with RISC-V, why it's important for us. So, as an organization that stores about half the world's data on some type of flash or storage device, for us, it's really about open interfaces, and we want to, as much as possible, ensure that there's open standard interfaces available for us to connect solutions into. And what's kind of been transpiring is that the architectures from a lot of the processor vendors, they're not able to, the traditional processor vendors use Moore's law. They just can't crank the clock speeds and put a lot more on the device, charge a similar cost and get cost savings. So what's happening is that there's actually interfaces that are starting to get locked down. And so we actually want to get ahead of the curve. And so one of the reasons why we are moving to this is to really make sure that open standard interfaces are prevalent and available so customers have final choices. So kind of that's the mind process and the thought process that we had gone through. And I think, for customers, it just depends on what their criteria is, what they're looking for. There's some general purpose architectures that if they're adequate for what the customer needs, then they can go ahead.
Hey, Ted, I kind of interpreted that question a little bit differently, where I was thinking you were asking about, is there an issue with design by committee?
Right.
Because in my previous life, I ran an organization called Embassy,
yes,
which did industry benchmarks. And I know that everything took 6x longer than you would expect it would, because you had so many different perspectives involved, right?
That's true.
So, not to stand in the job of the moderator, but how do you think that approach is being handled within RISC-V?
Yeah.
So certainly we have several task groups that are involved in the foundation to try to move things along. One of the things that we've done is actually bring on some additional resources to try to accelerate that. But the reality is that collaboration sometimes does take some effort and time. So there's pluses and minuses to it. We think that working together, kind of putting the ideas on the table, hashing it out, arm wrestling, what have you, but then arriving at what is the final implementation is of better value. And I think the one thing that the foundation has done a good job of is freezing these specifications, and that allows a really solid base for customers to invest in to move forward.
Okay.
So it is low. It is low. Sometimes it is low, okay?
Yeah.
But let me give you the other side of it, specific data point. So I'm working on the security side, and I figured out that something was missing in the requirements, right? So for people familiar with ARM and trust zone, you can cut the word in two, secure and non-secure. Well, the requirement these days is to have multiple words, because you have multiple secure things that you want to keep separated. And so I was able, as an individual, just to be part of these groups, the security group in this case, and add those bits into the physical memory protection system, whatever, to make this work. Well, it took 1 year, but hey, one guy did it, and it's out there, and it's working. So it takes a little bit longer, but I think the plan has been openly shared. This is the platform for the next 20, 25 years. So, well, let's get it right?
Okay. Cesare, next question to you. ARM is investing heavily into areas like certifications for functional safety, standardization of software platforms, security frameworks, and an enriched ecosystem. And obviously, this reduces efforts at licensing partners and further down for users of silicon devices, as they can rely on such fundamental work. Which efforts is RISC-V investing to help their user community in similar ways?
Well, I think you have the, the chair of the marketing group here. I would pass this question directly to you. So you are the best one to address this.
So I mean, we have not today, done specific work for functional safety. So there have been and are implementations where some of the clients, some of the vendors are actually, because again, they control the architecture. So the fact that it's almost the equivalent of the vendor having a microarchitecture license, so they can implement and do a lot of interesting things with RISC-V. To just kind of give you an example, Thales works with Ant Micro. Those are both member companies, and they actually put out a TMR, triple redundant architecture, which was something that there's now tools available for, and it's available for further development. So that's kind of a little different way to solve the problem.
Okay.
And I get an extra question now.
No, you won't get it. The next question is,
Ouch.
You have lost your spot.
You owe
Sorry
me a question.
for that.
You owe me a question. Okay?
Markus, some of the commercial RISC-V IP vendors offer extensions for AI and ML acceleration. On the other hand, today there are several hardware accelerators which are put on the side of general purpose processes. Which concept offers which advantages and disadvantages?
So I think this all comes down to cost of implementation.
Okay.
And if you're trying to do some basic, for example, convolution acceleration, 3x3 matrix, for example, it may make sense to use a RISC-V core on a small MCU, because square millimeters on a chip is really what the key thing is. When it comes to adding an accelerator to, for example, one of our higher-end i.MX products, where people are looking for 2 tops to 10 tops to 30 tops of performance, then having some dedicated IP block, whether it's a Google TPU or FPGA or something like that, will make more sense than having a core that has basic instruction extensions.
Okay. Tim, I want to remember you to a company called ARC, which offered completely configurable 32-bit RISC cores and was a huge attraction to customers because they could use only what they needed, reducing silicon size, power consumption, and improving performance. As a result, ARC was very successful also with big customers like Intel, Fujitsu, SanDisk. Does ARM need more flexible offerings to compete successfully with RISC-V IP in the future?
That's a really good question, and I think the answer is possibly. And ARM, I think if you look at the history of ARM, we've always evolved our technology as the world changes and we see different needs. Talking about things like custom instructions, there are some very clear advantages as to why people don't want to go down that route, and some of them we've talked about today. And as I say, the world changes. We're looking at this, what ARM are terming this 5th wave of compute, where there's going to be lots of fairly intensive processing on the edge, and maybe there is more of a requirement for local acceleration and doing things a little bit differently. You know, if you look at the history of compute, we've sort of seen accelerators sort of be born, and a lot of them end up back into general purpose sort of architecture and microarchitecture. Some of them, you know, are persistent, things like graphics and video, where, you know, there's a clear advantage to keeping them separate and burning the silicon area and all the rest of it. So there's sort of this history of accelerators popping out, going back in, and you know, we've seen things like, you know, MVE extensions going into architectures to solve some of those problems. I will go back to ARM's cores are very, very configurable, and you know, even looking at what we see from the RISC-V, if you take our smallest processors that are configured with the absolute minimal, you know, instruction set for the M-class instruction set, they're competitive and small. Do we need to do more? I mean, we always need to evolve our technology offering, and clearly, you know, I've said we sort of look, we will always be looking at ways to make sure that we're solving the problems that our customers need, and accelerators is an interesting place right now.
Okay. That today ARM is a de facto way people build embedded platforms. How big the challenge is to break up existing ecosystems can be seen in Intel's dominance in the server business, where ARM has been biting its teeth for years. Why should it be easier for RISC-V to enter ARM-dominated markets in the future?
I always find it interesting that whether I'm on a panel or being interviewed, it's always this, you know, ARM versus RISC-V, and I really wish we could just kind of move on. The reality is that there's places for these architectures to coexist. Yeah. And I'm like really surprised that people don't recognize how often and how many devices, millions of devices in fact, are already shipping that have both, right? So whether it's a RISC device in an embedded core, where it's an ARM A-class device, or what have you. So I think the reality is that there are going to be approaches that certain customers, certain vendors will have, where they want specific purpose-built architecture, where the value of, you know, having the additional customization and the ability to really fine-tune will put the ball in RISC-V's camp, and they'll move forward. You know, we still have a lot of development that we have to do. The organization, the ecosystem has really grown significantly over the last couple of years, but we still have a long way to go. There's many tools and things that continue to need to be developed. So it's not an either-or answer.
Okay.
Well, this is a panel discussion, and we're supposed to have some controversy too, right? But I could say that, you know, it's not the ISA wars are kind of over. I mean, I remember them from decades ago when it was RISC versus CISC, and then there were so many proprietary ISAs, and they all kind of just gyrate, you know, towards ARM, right? And it's not to say that I'm pro-ARM, but I'm just saying here that this isn't an ARM versus RISC-V. It's really understanding the positioning of how these things can actually work together. And you got to remember too that RISC-V is an ISA, and it's what you do with that ISA, right? What kind of an implementation do you actually create? And you know, we're definitely playing around with that architecture inside of our company to figure out how can we make our own pipelines and, you know, build cores out of these things, because we can, right? And so this is what makes it really interesting.
Yeah,
it opens up a whole new playing field.
So for the sake of the panel conversation, I think something that we didn't touch is the Moore's law and what it means for general purpose processing, because that's really what's happening. And this is not just ARM. We didn't mention Intel, but Intel number disappointed recently a lot. And people familiar with Intel know the tick-tack or going tick-tock. Yeah. So faster processor, better ideas on top of the existing node technology, and then repeat, and that's over. So I just bought a new laptop. It doesn't go faster. And so I'm questioning, so why would I buy the next one? Apply this to everything else out there. So there's really a need in some applications. Extreme low power, for instance. I've seen a project presented at the conference. It's a university, so no commercial one. It's the ATH Zurich in collaboration with another university. They were able to reduce the power consumption on an energy harvesting device for biometrics compared to the ARM implementation by 90%. That's 90% out of the best-in-class low power, because they cut out basically anything they didn't need. That's an example. Another example in RISC-V, there is a company that puts 4,000 cores on a die for machine learning applications. That's Esperanto, right? So these are the kind of things that you will never find a general purpose processor vendor for as much as articulated as they're offering to fit all of these specific requirements. And I think innovation is going to happen there. So totally agree, we'll coexist. I don't see a SKU replacement one-to-one, but you're about to say something?
I might do.
Go.
No, I think it is really interesting, and that RISC-V versus ARM thing, I think we all sort of sit here and go, it's not that, right? And ARM is a very different company from an ISA company, right? We have an ISA, we also have IP and systems and ecosystem, and you know, I absolutely love the innovation that's going on in and around RISC-V, and ARM will benefit from that too. You know, there's no doubt about it. This is just technical innovation, and it's great that there's a tool out there that everyone benefits from, and you know, again, this sort of. And then Cesare did the comparison again. He went, but there's something against the standard ARM implementation.
I mentioned Intel too.
And
to be fair.
And yeah, if you pick a standard off-the-shelf MCU implementation from ARM, then it's not going to compare with something that's been designed for energy scavenging or energy harvesting applications. But you know, believe me, there are ARM implementations out there that run clocks off potatoes, and you know, we're looking at all sorts of technologies and huge amounts of research that's done in the public domain around low energy solutions, and I think even though we're all sitting here going it's not a competition, I just wanted to pick up on then we get compared to a general purpose implementation against something that's been done very specifically for a specific task. There are ways of doing that with ARM implementations. Now, no doubt RISC-V offers opportunity for innovation and differentiation that goes beyond what comes from an ARM standard product, but there's fundamentally nothing in the ISA or anything else that's going to create that differential.
So before we are running out of time, unfortunately, by the way, no questions from the audience came in so far. If you like to ask your question, please do it now. I can't say, okay, I will call you later. My last question to Cesare regarding security. You mentioned all the elements which are provided by RISC-V, the 4 rings of trust, the secure interrupt processing, the physical memory protection, but doesn't need a architecture, also a framework for endpoint to cloud security like PSA from ARM is providing today?
That's a great point. I love that question, and I think it's an important aspect to it. ARM, being the proprietary vendor, is able to drive a strategy around the platform. And in fact, they, I think, branded PSA, Platform Security Architecture. That's something...
Yeah, but it's open.
And that's something really good, okay? Because it gets out of the core and extends to anything you need to put together, right? In the SoC, in the board, in the system. That's something that really one vendor can drive. In our conversations within RISC-V, I ask this many times. So what happens when I go outside the core, other bus masters? And the answer is this is not the job of the ISA. But still, we need to secure the rest. So luckily, there are independent global standardization bodies that would eventually fill that gap. But as of now, I think that's a plus, actually, for any proprietary vendor to be able to drive their own platform. Now, as far as how secure things are, anything can be broken. And so I go back to the point where perhaps there's something unique, not in the product, in the core, in the technology, but in the model around it, which is the whole world can participate, look, and make it more secure. While when it's proprietary, obviously that's a little bit more difficult, at least, okay?
Okay.
And can I just make a comment? I mean, I think in that security domain, it is really important that there's no point scoring. You know, this is a real problem that everyone has to solve. And I think with the PSA thing, ARM did take a technology leadership position because I think the industry needed it at the time. And I'll just do my marketing bit. It is open, and it is any architecture. It's not tied to the ARM architecture. It is for the industry. Now, is it perfect? And are there different ways of doing it? Absolutely. And over time, hopefully, we evolve that. But this isn't about point scoring. This is about doing the right thing. And I think a lot of our security architecture is open and open source.
Okay. So, please ask your question.
Yes. I hope it's okay. Thanks for the nice panel, but I think what you kind of left out completely, I'm an EDA guy, I'm coming from working for NXP and for Mentor Graphics. So my question to you is, in what sense is RISC-V interacting with the EDA companies? Because there I see the big bottleneck. I mean, you said, for example, Moore's law is over, and I don't know why we need other chips. I say automotive, we have huge problems where newest technology modes come together with huge safety and security aspects. And I can tell you, as far as I know, not all the industry, maybe NXP says, yes, we do, have solved all those problems. I say ISO 26362, for example. So my question in the first place is here, in what sense does RISC-V work together with the EA providers? Because, and also, how do you see security aspects?
I can't really hear. I don't know if I'm too close to the... Can you repeat the question?
I think the question was which EDA providers do you collaborate in the RISC-V ecosystem? Which EDA vendors are supporting RISC-V?
Well, I'm not going to answer that question. I was just going to try and clarify it. I think the question with things like functional safety and need for close collaboration with EDA.
Yeah.
What are RISC-V doing within the EDA ecosystem to solve that problem? I think is a question.
Yeah, this is a question for the foundation. That's
what I want to take.
Cesare, always, It's so again, what's that?
Two questions.
No, you're done. So there are member companies that are like Mentor, for example, is part of the foundation, and that's something that we're constantly doing is looking to have additional members into the organization. I also mentioned the example of Thales, right, where they've joined the foundation, been taking a leadership role, have put together this safety security triple redundant processor. And so, this is part of the ecosystem that's going to develop and it's going to evolve, right? So we don't have all the building blocks that every customer or corner case really requires. And that's just what we're developing. That's the reality of where we are today. I mean, 2 years ago, we didn't have a lot of these things. We have a lot more today, and we'll continue to accelerate the development, but we don't have all the pieces.
Okay. Sorry, guys, we are running out of time. Could you discuss this offline after that? I'd like to thank you very much for panelists. It was a great discussion. Thank you so much, and I wish you a great stay on the exhibition ground. Have a successful day at Embedded World, and see you next time. Thank you very much.
Thank you.
Dankeschön, Markus. Thank you. Thank you, Tim. Thank you, Ted. Oh, great.